All right. So, one of the things I observed working with the crossbars and the axons that connect signals between crossbars is that there's quite a bit of crowding on popular destinations. In particular, BV's rear wheels, the left motor and the right motor. There's a bunch of signals that would like to reach it. And, well, at the moment, there's two signals. There's one signal coming from the gray sensors to correct to try to get it BV to drive in a line. Then there's one coming from the major grip itself, saying, do yellow, act like a yellow Breitenberg vehicle. Do pursue, explore, avoid. So I decided I would take the time to try to make dendritic trees. Instead of just single point-to-point axons, we would like it to be possible to have a bunch of signals fan in to a single destination. And, sure, if the thing is running at capacity and there's signals everywhere, that's going to cause things to slow down. In other words, they will start to block each other in the net in this dendritic tree. But they would have blocked each other once they got to the motor anyway, because it only gets as many events as it gets, and it's only got 4 adjacent spots that it's willing to take signals from. So I wanted to do a quick demo. So we've got things called SD up here. That's a sensor debug and motor debug. So basically we're making fake signals that will send from sensors to motors. And so if we let's do it over here, say. So if we put out a sensor and a motor, all right, so the sensor is running the flood find algorithm, trying to find the motor. It'll find it once the flood gets close enough that it can jump. So like one more step, it'll probably get it, and then it'll race back to the sensor. There it goes. And whoever wins the race gets the signal. Now, you should be able to see signals flashing through there every so often. It's so hard to do it backwards. The sensor randomly injects signals and then zoop, off they go. But we can have multiple sources. So let's make another sensor there. And deliberately I made it close to this knob right here. And now, there it is. So now this second axon terminates on the middle of the first one, and signals from this second source will jump this gap and head on up. They will block if there we go. There was an example, and we can just go crazy. I don't have a lot of experience yet. This just got started working with having multiple floods going simultaneously, so this is being a little bit risky for a demo, but so far it looks okay, I guess. And yeah, of course. See, now this is another important point. Okay, I inadvertently put down a whole bunch sensor sources, so I have no idea what's going to happen here. Well, we'll see. So far it looks like 2 of these SDs, the sensor debugs, have successfully flooded and found a path. This one has found a path, and this one over here. These other ones keep on trying to start a flood and then give up because they're seeing existing stuff or something like that. Maybe I'm going to just put these guys out of their misery. Can that guy go? Oh, he was... Oh, I guess this guy just hadn't quite finished. I don't know. Anyway, so I cheated there. But we can put some more down. And I started to say that that upper one had found a particularly inefficient path because it could have gone straight down and been fairly close to the main drag heading for the motor, but instead it just happened to find one that was actually quite a bit further away than it needed to go. And my point in mentioning that is that the way this is designed at the moment, finding any axon midpoint that is destined for where we want to go is good enough. There's no sense in which this axon path is longer than that axon path, because I didn't want to spend the bits to have to count axon length and get into all that sort of thing. So at the moment, it just goes with the who wins the spatial race. It doesn't matter whether it's like we had here, a far away one. I mean, if we, all right, so the motor's right here. So if we put another one right here, we'll have a good chance of getting a direct shot like that. Boom. But we can also get ones from much further away. And I haven't really tried this very much either, but it ought to work. And again, the load on the main axons, the load getting closer to the motor, closer to the destination in this case, continues to increase because each of these sensors is it's got just some random number about how often to try to inject a signal. Okay, now that looks really bad. This I've seen before. Yeah, I do not know what happened there. It's a little dementia axon tangle thing, where I think what happened was it thought it had a destination, but missed it, and so then the axon continued growing randomly until, in this case, it actually lucked out and found a all right, that guy worked. So I haven't seen a repeat of that. All right, so now this signal, this pitiful signal, whoops, here we go again. Jeez. These pitiful signals are working their way through this axon tangle, trying to get to the motor, and they will get there. I would not want to have something time sensitive on this signal, but that's the point. And so once again, we can probably throw some more in. And see what they do. And now presumably this one up here is going to, yeah, it terminates on that horrible, incredibly long one, and because it doesn't care. But I kind of like this. I am going to redesign. At the moment, it's just this spike demonstration, but it's all being set up. And in fact, originally I tried to just go straight for the redo BV's brain to use this stuff, and of course none of it worked, and it was completely impossible to debug because it took forever for the BV's setup to happen and so forth. So eventually I broke down and made these little test harnesses to debug all this stuff. Let's put some more in while we're still sitting around here. I don't know why that was. Oh, yeah, I do know why. So this one's going very slowly, and it found an unexpected destination. All right. Another one here, another one here, another one here. Everybody wants to talk to the motor, is the idea. And they will find a way. Life finds a way. And I think, and I really haven't debug this hardly at all, I think if I kill one of these axons, then it ought to clean up, and the sources that had been connected via the one that died, I think will regrow. Do we dare try that? Why not? But I'd like to get these two existing ones here settled a little first before trying that, and then I'm going to try to do an anti-dementia thing and try to clean up that one over there. So is that it? I don't know if those look awful. There is a limit on how far the flood will go, and it's possible that that's reached its limit? If so, we ought to be able to fire off another one. Oh, that's not going to help. Fire off another one. I have to blow my nose. Oh, sorry about that. Or something like this, maybe. Trying to get a new one. Well, you see, but I can't even really do that. Well, maybe. The point is, I have to put the sensor, the seed for the thing, right next to the. Oh, but then it won't even. Yeah, I'm not sure we can do these. Maybe I'll just go ahead and kill these. Oh, there's another one. Both of these look like they're close to tile edges, which is completely superstitious of me. Oh, and that caused a third one. Oh, man. All right, well, it was a screw up, but it ended up getting the thing. All right, let's just kill this one. All right, so let's see what happens if we kill this original. All right, so it starts dying back. Let's get a closer look at the action here. Oh, and indeed, this guy started to regrow. Now, the signals here are backing up, but this thing does not appear to be dying back, which seems wrong. So that's another problem to deal with. Why is this not dying back? Because he thought he was at a midpoint. Well, he is at a midpoint. Well, I wonder if I should actually get a little debugging info. We're recording a demo. All right, so I'm going to stop the simulation. I'm going to get my debug enable Atom. I'm going to put it next to this guy and enable his debugging. So this debug util's changed to true. And now I'll give him, well, actually, I'll clear the buffer over here so we can tell what's associated with this thing. All right. So we have a bunch of debug output over there that may tell us why this thing isn't cleaning up. Oh, it's got an up and a down. So, because it's got an axon head sitting here. So a better question is, why is this axon head not cleaning up? Oh, because it still thinks it's found the tap. All right, I have an idea what the problem is with that. But it says that if we kill that one, then this chain should start cleaning up. Yeah. Well, we've got quite a few little issues there. So they're only dying back part way. Let's get rid of that. And this is now, oh, look at this. That was great. We've got two heads facing each other, and now the signals are going the wrong way. So a little work to do, but let's oh, and yeah, I've seen this bug before. That this is now looping. It is possible for a signal. Now, again, I actually already debugged that to a certain degree, but obviously there's cases I haven't covered yet. So once again, let's flush these. And let's see if they can find something a little better. All right, so this guy looks like he's actually found a legitimate path, and that guy's found a legitimate path to him, so we're in much better shape. And now signals are moving once again all the way up to the one and only motor debug that we've got here. Stuff is, and now we've got one of these loops that is packed full of signals that are going nowhere. So again, all right. And no, we don't want you to find that. You guys got a long way to go. Let's actually just kill one of you. Alright. Now, again, yeah, that should be enough. That should be enough. It's got one more step. Oh. And it found an alternate path. Anyway, so it's fairly legit. Let's put a few more down. Far away from each other, though. What do you say? And let it build its network. Yeah, and there we go. And I don't know if this one down in the corner is going to be able to. Again, looks like it might be getting fairly close. And it looks like not. Let's put another one in here. Put one right between these two guys, see which one it finds. Over here, another one way up here. So I had all kinds of great plans, of course, about how to make this adaptive so the paths could straighten themselves and even perhaps open up parallel paths, additional lanes, that kind of thing, based on usage, so it would all be self-optimizing and stuff. And it's all of that stuff, or some of that stuff, may still be possible, but none of it exists yet. This is brand new. And here we've got another wandering guy there. Really gonna have to fix that. Although, as always, not as so often, put it that way, the bugs are quite interesting. The behavior of the bugs. So it looks like I think this is sort of consistent with seeing a tail and thinking during flood that it could anchor on the tail, and then when the axon was growing to fill in the flood path, deciding it couldn't, and so the head just wandered off, saying, obviously I haven't reached my destination yet, because look at that, this thing grew right up here. It could easily see the the tail over here, but it didn't hook up because it's not allowed to hook up. It has to hook up with a mid, not a tail or a head. So in fact, that's probably the conceptual bug right there, and one just has to and this still, oh no, here we go again. I'm gonna wipe it out, wipe him out, kill. All right. Does not appear to be one left. There we go. Okay, I'm going to try one more time to get something that will help this guy. It needs to grow around the existing stuff, branch, anchor onto a existing path, and then win the race back in such a way that the new path is, we got a chance here, in such a way that the new path is close enough to one of these things that, all right, come on, let's do it. There's the path, racing back to the root, and now it's going to grow an axon forward again, following the path of that. Yes, look at that. And now this giant wedge of flood can finally resolve itself, which it really should have had a timeout and cleaned up without my intervention. But, there's a million things like that have not been systematized in any reasonable way. So here we have it. We have a dendritic tree that is sending a whole bunch of signals that all get consumed right here at this little guy, a debug motor guy. Yes, the motor debug 10, and all he does is sit around and consume the signals that arrive anywhere. And in fact, he's got three axon heads. Yeah, they've kind of crisscrossed. So he's only got room for one more axon head that could terminate directly on him, and all the other ones, if they wanted to have any, would have to terminate somewhere out in the tree. So, a little cool. And this is what, a half an hour of yakking. All right, let's call it.